All right, so step one, redraw this on your paper. Does that seem like a reasonable sketch? 67 looks a little shy of 67 degrees. I don't buy it. So 45 would be, wow, that's only 45-degree angle. 67 would be, I think, up here-ish. I'm going to draw it a little bit different than they did to be more to scale.
Steep mountain.
Yeah, that's wicked steep. Now I want to put a cell tower on that. Okay, so we're at 67 degrees, and then we're going to measure up. So 165 would be this length there. And then we're going to put a cell tower at the top, which is going into my picture. Oh, well, I don't have much choice. Here's my cell tower. Beep, 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 beep. It's right there. And so I go from there to here, then I get this extra angle right here. And that one is 16 degrees.
Is it going all the way to the bottom or just?
It's got to, otherwise it's useless to us. So I could so their sketch isn't that great here, but if I were to say, maybe this is where that ends right there, and I just draw a parallel line to the ground level,
It's still the same.
that this angle right here is still going to be 67 degrees. So either way, we're okay. All right, so this is a little, but my picture's a little more, shows that looks like more like a 45-degree angle. This looks more like 67. So let's draw a line down here. That would be a right angle. Okay, so this is what we have to work with. What do we want to know? Guy wire is going to be attached 165 meters downhill. Okay, and we want to know how long is the guy wire. Right? So we want to know how long is this right there. Okay, what are we going to do with all this? Let's see. 165. All right, it's there. Does the 67 come into play? Yes, it does. All right, so my triangle of interest really is this one right here. That skinny triangle I drew in there, which on their picture would be this triangle right here. So we need a little bit more information on that triangle. So at the moment, we know this side right here is 165. I'll relabel that. We know this angle right there. Can we find other angles? And I believe that I can find this angle right there. And I can do that because I can find that angle right there. So since this angle is part of a right triangle, it's going to be 90 degrees minus 67, which is going to give me, what, 23 degrees? Sound right? And if that angle is 23 degrees, this is a straight line cutting through that point. The red angle and the blue angle have to add up to 180. So in their picture, I claim that angle, right? Oops, wrong color. That angle there is 23 because it's in this right triangle. And if this angle here is 23, that 23 angle and this blue angle here have to add up to 180 because they form a straight line. So this angle right here has to be 180 minus 23 degrees, which is going to give me 157. All right, so I have this angle here. I have this side. And I have that angle there. So I'm thinking this is probably a law of sines problem. 165, that length is opposite which angle? The 16, the 157, or the angle I haven't found yet. 165 is opposite which angle? It'll be this one up here. That angle is opposite this side. So I'm going to need that angle too. Well, I know two angles in that triangle, so the third angle, just another subtraction. So that angle up there is going to be 180 minus the 16 degrees I was given, minus that 157 I just found. Do I need to resort to a calculator?
Seven.
Oh, not yet. What's it end up being?
7.
7 degrees. Thank you. All right, so that angle there, 7 degrees. And now I'm ready to do this. So I want to find this side over here. I'm just going to call that X for that side. What's X's opposite angle? 157. So X over the sine of 157 degrees is going to be equal to the 165 over the sine of its opposite angle. Should be that 7 up there. And again, if you wrote it the other way, you have to cross multiply and divide. If you wrote it this way, you can just multiply that sine of 157 up. So I think X should be 165 times the sine of 157 degrees divided by the sine of 7 degrees. And my picture's slightly more to scale than theirs is. Let's calculate that and see if it seems reasonable. All right. So I've got again 165 times the sine of 157, right? Over the sine of 7. $529.01-ish. Did I type it correctly? Like it. I'm in the right mode. I am. Okay. 529. Anyone else get that? 529.01-ish. And that would be meters.
Not degrees.
Not degrees. Oh shit. Oops. Meters. All right. Let's see. My 67 doesn't quite look like 7 up at the top, so it's not really to sketch. 16 degrees would be a bit bigger. So if 16 degrees is bigger, then, you know, maybe my line goes up farther like that before it hits the top. Definitely more than 165. I don't see a flaw in my reasoning at the moment. The only other thing I could do is get a clean piece of paper and redraw and see what happens. So I would, at this point, put myself at 90% certainty that I have the correct length for that guy wire. That was interesting.